In this video, I'm going to outline 4 types of measuring scales. I'll start with the simplest type of measure, the naming scale, which is just a listing of the names of things. For example, you might want to know what sort of pets your friends owned, so you would write them down: dog, cat, budgie, rabbit, hamster, and so on. So that's the naming scale, just words. Next is the ordering scale. It's about naming things as well, but the twist is that the words have a natural order. For example, you might be listing the months in which your friends had a birthday: March, December, June, January, September, and so on. But since there's a natural order to the months of the year, it would seem logical to rearrange them like this. So that's the ordering scale, words that have a natural order. So far the scales have just been words, but normally when I think of a measuring scale, I'm expecting some sort of numerical measure. As you'll see shortly, there are 2 types of number scales. Here's an example of the first one. You might be measuring the air temperature repeatedly over a few days, and this will give you a set of numbers. Measured in, say, degrees Celsius, you might end up with something like this: 12, 14, 7, 11, 6, and so on. Now here's another number scale. You've got the job of posting off some heavy parcels, and so you weigh them. Measured in, say, kilograms, you might end up with similar numbers, again, 12, 14, 7, 11, 6, and so on. Now, these are both number scales, but they differ in one particular respect. Look first at the parcel weights. The weight of the first parcel is 12 kilograms, and it's twice the weight of the final one, 6 kilograms. And that's fine. As you can see by comparing the length of these 2 bars, it does make sense to say that one parcel is twice as heavy as the other one. Now look at the temperatures example. It would be tempting to say that the first temperature, 12 degrees, is twice as hot as the last one, 6 degrees, but actually you cannot talk about one temperature being twice as hot as another. The reason it worked with measures of weights was that 0 kilograms means no weight. So here the 0 is fixed. But with temperature measures, 0 does not mean no temperature. So here the 0 is not fixed. Because the 0 is arbitrary, you don't actually know how long the bars are. For example, I'll move the starting point of the bars to the left like this. And now you can see that the longer bar isn't twice the length of the shorter bar. The only thing that hasn't changed is that the interval here is still 6 degrees. In other words, you can only compare intervals. And this is the clue to how this sort of scale is named. Measures like temperature use what's called an interval scale. Now with weight, you can compare using intervals, but this measure has an extra trick up its sleeve. You can also compare any 2 readings using ratios. This allows you to talk about 5 times as heavy, twice as heavy, and so on, and it explains the name of this scale, a ratio scale. So these are the 3rd and 4th types of measure, interval and ratio scales. This way of thinking about measurement scales was devised in 1940 by Stanley Stevens, and it's known as the Stevens taxonomy. In fact, he used the slightly more formal terminology of nominal, ordinal, interval, and rational. And although his classification isn't perfect, I do find it a useful way of thinking about measurements.